Hey everyone, welcome back to the next version in our Learning Python with Blender. So the last time I was having some issues with what's over here, and instead of like I'm not sure if maybe you wouldn't do it. I guess you would highlight it in Word or something. So just click on the statement, then hit copy, then we can go over here and hit paste. You actually have to select what you're doing over here, and I hadn't selected anything, so that's why it. But again, now here's this whole thing, and if we run, so here I'm gonna, let's see, I'll back this, whoops, that's not gonna work. Uh, put this here, and I'm gonna move this one over here, and we're gonna run this. And it didn't move it. Oh, Blender. Yep, that's why. Okay. Because I haven't added in, and we'll get to that in a little bit, so I'm not going to jump ahead of ourselves because we'll have to get there. But this will run. When we set it all up right, this will run, and you can go in here now, and we can change any of these or remove them if it's possible to remove them. All of the things that make that change that we did happen are sitting right there. And that's probably really complicated, but you'll get it. I promise you'll get it. And this is something I don't know. As far as I know, it's not available in Maya. It's not available in Max. It's not available in anything else that you can built into the program. Is it helping you learn how to use the program with coding? Because coding does stuff that the program can't do by itself. You can't write a game engine without coding. No matter what I can make really cool and sculpt and render and do whatever else, I can't make it operate without coding. I can't make it do something. If you look at any of the other game engines out there, Unity, and the other big one, Unreal, you'll see you got to learn coding. And they're C++, but there's nothing in the program that tells you, well, this is what this does, or this is what this does. You have to go read that somewhere else. There's still a lot of documentation, but it is so cool that you can just find that right here and start working without looking up every different thing that you want to do. So the real thing that we wanted to do here is we want to get into our variables. So if you remember back to algebra again, variables are a word, letter that is representing something else. So we'll go back to the same thing we've been using. So x equals 5, y equals 3, and read equals hello. And we're going to go z equals 6.2. And there's one other. And let's do. Yeah, I don't know where these are coming from. Equals true. All right. So these are your basic variables. This first two are integers. They are whole numbers, positive or negative, including 0, and they can do all the math. That's just the whole numbers. They always stay whole numbers except division, because you're going to end up with a decimal most of the time. You can even do a certain type of division and stay with integers. And integers are great for counting because we don't care about what's beyond the decimal. We never want it to use that if we're counting through loops or something else like that. So let's say we want to create 18 of those cubes. We need it to go 1, 2, 3, 4, 5. It needs to be an integer. 1, 1.4, 1.8 doesn't help us. You can't create 1.4 of a cube. That just doesn't work that way. The next one, and I'm going to go in order, is what we call a float. Here's where when you're doing division, when you're doing rotation, when you're doing scaling, even when you're moving something, you can do a partial part of a unit that you're moving it. That's where you want the decimal. You want the accuracy. You need it to be as accurate as possible. And it can go out. I don't believe there's a limit. There might be a limit, but it's like 256 characters beyond the decimal point, nothing that we're going to worry about for a long, long time. Okay, and then there's two more basic types. We already worked through the hello there with read as a string. And the string is whatever inside the quotes exactly as it is inside the quotes. If we make another variable called great, then, and we put in this is a string, space, 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 space. What do you think of it? Wow, my brain's just going weird today. And we ask it to print great. And we run it. I need to take this out. And we go ahead and run it. Go over to our console. And it's printing exactly what we typed in. All of the white space, all of the punctuation, everything exactly the way we typed it in. Capitalization. It doesn't change a thing. It just regurgitates whatever you put in there. So that's a string. And then the last one is called Boolean. This would be the one you may not have been familiar with, but you are familiar with it. Boolean is from a mathematician way back when. I don't remember exactly when. And it means true or false. Those are your only two options, true or false. And the reason for that is that's what we use to make decisions. Computers can't really make a great decision at this level of did you like the book or not. But you can ask somebody in a program, did you like the book, get their answer, and translate that answer into a yes or no. There is no maybe. That doesn't exist. Computers really don't like maybe all that much. What they're probably going to try to do is if you give it a maybe, you're going to have to sit there and figure out, well, you're going to need to get it really close to a true or false. That's just how computers think, for lack of a better word. You need them, when they make decisions, it's either a true or false. It's either a true or false. Even if it looks like it's making a maybe decision, like saying, well, you might like this, it went through all kinds of things to come up with what those options are, and the you might like is probably something that the human being typed in to make you feel like you're being helped. But the computer didn't think that way. It's saying yes or no. Is this thing like the other thing they ordered? Is this string close? Is this string what you searched for? And a lot of times when you search for two different words, you will get a whole bunch of stuff for one of them and a whole bunch of stuff for the other one, and maybe nothing for the two of them together. You have to put it in quotes, but it's only right there. It's like a binary choice, true or false. It's probably a whole lot of explanation. I hope you understand just the way my brain thinks about it. But those are our four basic parts of variables, and that is the crux of what computers do, is use these variables. Now, why do you want to use a variable? So let's do it, like, do some simple math. So we're going to go x times y. We'll have to do it this way. Actually, let's go over here and do it. X times y. And we get an answer. But why would we want to do that instead of, what do I have them out here? 3 and 5 and 3. Why didn't we just do 5 times 3? Same answer. The reason is that x over here in the code, x is here. And let's say we were using 5 students and we're trying to figure out what their grade average is. And it's going to go through, and we'll worry about this later, but it's going to go through from a class of 20, 5 students. That's what you want to look up. What is the average of 5 students? Well, maybe the next time you run the program, you want to do 7 students, maybe all 20, maybe 4. If you left it as 5, you would have to go inside your code, find every instance of the 5, change the 5 to 7, resave your code, and rerun it. Whereas by using a variable, I can simply ask you, how many students would you like to put into this? And we can assign that to that variable when we start the program. And then we type in X, and every time it runs the program, it's going to use whatever you put in there for X. And when we start, we're probably going to do a lot of this where we just put it in there at the beginning so that we can have an example or whatever we're trying to do. But that's why you use variables. We can make strings different by reassigning them. We can check true and false. And therefore, when we ask, is book good? That would mean true if it's good and false if it's not. Book can always have that answer, and we don't have to retype in each different book. We can just say this book equals this, and does it do this? I hope that makes sense, and it will make more and more sense as we go along. So that covers our basic variables. There are others, but they all kind of get based off of these. They're made up of these. They're the ways of collecting and using those basic variables to do other things. And then we also went over the REPL and the info box for here in Blender. The info box is unique to Blender. The REPL and the coding part here is going to be in just about every IDE you look at, whether it's VS Code or PyCharm or the IDE LE that comes with if you install Python yourself, all that. All right, so the next one, we're going to go into a little bit more Blender and start moving around in the normal screen. Thanks. Bye.